Hello and welcome to Physics Problems 1 by 1.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
So, we have an air balloon and it sits on the ground and suddenly it starts moving up with acceleration a. It's not falling down, it's moving up and it's accelerating. And they gave us this acceleration. It's like they gave us 1 meter second square. So if it would be falling, it would be 10 meters per second square. And here it's rising up 1/10 of this. So it's rising fairly fast, but not as fast as if it would be falling. Okay. And then tell us that it's do so for 10 seconds. So A is known and T capital is known. So when time T expires, it would be here, H would be H, height. And let me draw it a little bit better. So it would be height and would be after time T. And then they drop something accidentally from here. And this is a question about the falling bodies that they dropped accidentally. So, first of all, we look on this and we know A and T. Immediately after that, and the body starts our movement from here. So we have to determine about this balloon. This balloon, if we know A and T, we know pause, correct. We know the speed, because final speed is initial speed plus AT. So we can say that the speed here would be V, and it would be 0 is initial speed of balloon plus acceleration over time. So we know that the speed of balloon is AT, and A is known and T is known, and if we put there we will get a very nice numbers. No need for a calculator. So that's the first thing. And let's draw here a body that's falling down to Earth. I just shifted so not to draw one against each other. So this body starts moving up with initial speed v0, and this v0 is initial speed of this body, and it's known, right? So it's known, and this is v0, and I will put AT there. And also it starts from the height. What can we tell about the height if we know acceleration and T? Of course, pause, you should write it. Initial speed of balloon, which would be 0, multiplied by T, time is given, plus AT squared over 2. This is gone because it's just starts with 0 initial speed, so we have H equal AT squared over 2. So we know the height and we know the initial speed of the body. So let's write it down. V initial speed of the body that's falling is AT, and height is initial position is AT squared over 2. And A is given and T is given, and we can easily put them in. And now we're coming to the body that's being dropped. And what happens, see, I wrote right away that this is V0, initial speed of this body that's being dropped. But why? Like, I mean, if the balloon is standing still, floating on this certain height, and we drop, this would be a free fall. But balloon is moving up, and if we just put our hand out and let the body drop by accident, the body will have initial speed the same as balloon against the earth. So the body will start with initial speed. So now it is a problem about, let's say this is x and this is 0, and we have the body that starts with x0 and moves with v0, v0. This is and acceleration is g. It has nothing to do with balloon anymore. So we can say that the formula for this body would be pause. Yes, you did it correctly. Initial x0 and x0 is h. And h is known. Plus v0t. v0 is up, so it would be plus. And v0 is known, and it would be z. And this would be time. Acceleration g down, so minus gt squared over 2. So, and then all I want to say is that when I want to find the time when this is equal 0. Because that means that the body goes up, stops, goes down, and this is xt, right? So xt equals 0, so I put here 0 equals, instead of h, I put known value, at squared over 2, plus v0, I put at, and I put t, minus gt squared over 2. Right? And this is all I have, and this is one equation with one unknown, t lowercase, a is given, t uppercase is given, given, t. So it's square equation. Let's solve it. Let's move it all to another side, and let's multiply by 2 in one step. So I'm moving 2 and multiply everything by 2. I have g t squared minus, and I put it in canonic form, 2at tau t, and I put another at squared, and all of this equals 0. And this is a good time to solve this quadratic equation by putting the numbers. G is 10, t squared is unknown, minus 2 multiplied by 1 multiplied by 10, right? Minus a is 1, right? And t is 10, so it would be 10 squared equals 0. So it would become 10 t squared minus 20 minus 100. Did I write it correctly or not? Looks good to me. Equals 0. So we can divide everything by 10, so it would be much simpler, and we will have, and I forgot here t, of course. I forgot here t. T squared minus 2t, right? Minus 10, right? Equals 0. And then I have to solve this quadratic equation. And to solve this quadratic equation, I say t12 equals 2. This would be minus 2. And minus over minus would be plus. And then I put plus because I don't want negative numbers. And I put here b squared, which is 4. Minus would be plus 4 multiplied by 10. And this will become 2 plus square root from 44 divided over 2, and we will get 2 plus square root of 44, it's approximately would be 6.7 divided over 2. It would be 8.7 divided over 2. It would be 4.3 seconds. And this is what it is. After this time, this body will fall to the ground. Let's find out just by drawing what happens with balloon at that moment. And so let's draw the same picture again. Let's say that this is X, and let's say that balloon X, aerostat balloon would be, let's say, X B equal 0x0, we know this formula, AT squared over 2. I wrote it already. From the beginning it will go up, and it will go up with this acceleration. And the body, let's put it x2. I wrote this formula, and I can write it again. AT squared over 2, its initial height, this h, and this is this, plus v0, which is AT over t, minus gt squared over 2. So if I draw a graph of the first body of the balloon, it would be like this. It would be x, and it would be t, and this would be 10 seconds. And from here we have the free falling body, and it will start with the same speed. So the tangent would be the same, but the parabola would be directed downwards. And when it would be this time 10, 14.3 seconds, this body will be here. So it will go up, it will have some maximum height for this body, so it will go up a little bit, then will stop, and then it will go down. And balloon, meantime, will go here, and the x of balloon at that time would be AT squared over 2, only time would be 14. So x of balloon would be A is 1, 14.3 squared divided over 2. Well, let's say very roughly, it would be 200 over 2. It would be 100 meters. So this h, if we want to put the numbers, this h would be 1 over 2, it would be 100 over 2, it would be 50 meters. So this would be the point where this would be 50 meters. And this would be the point where this would be 100 meters. So it's not very proportional. If I would draw this, I should draw it not going up that fast. But basically, that's it. The balloon goes accelerating up, 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 and up. Body starts with the same speed as balloon at that moment. So the tangents of those two parabolas are the same. So they're touching each other nicely. But this parabola is directed down, and at 14.3 seconds body comes here. Meantime, balloon is keeping accelerating up and gains 100 meters of altitude at that moment. And that's basically all about this problem. So don't forget to subscribe, bell, like, put a comment, and I see you next time. Thank you.